This methods, a type of methods are called direct methods. Okay, so this is the direct hashing of an employee number. I just say directly your key value finds a location where the records are stored. Now we start with the three numbers. So then we have a appropriate hash function 005 and 100 and 002. So this and this are not related. I mean, knowingly, these roll numbers and this thing is never mapped or I mean matched or informed about the design. So here system is you are assigning roll number that is unique. Here you are maintaining a table that is unique. So we take a help of a hash function to transform from this 005 address or 100 address or 002 address to this. Okay, so this is the direct hashing. Again, I repeat, if you are taking 7409 is the number with you, then I am directly putting the things or alerting you or allow. Suppose you are coming with a vehicle and there are number of car parkings and it looking into the 4 digit of your bike or a car and it allows you go to that parking. So this is the example of the direct hashing. Okay, directly these locations are mapped. 005 information stored at 005, 100 information will be stored at the 100 location. Similarly, key number 002, this information stored at the index. So these methods are there when we have very few amount of information where it can be directly accommodated into this field. Okay. Now, the second method is subtraction method. You see all about the way you try to manipulate the primary key. You can suggest many methods and sometimes some bits has to be added, sometimes some operation has to be applied. Then we generate a unique key. So direct and subtraction hashing function guaranteed the search effort with one search effort of one with no collision. What happens during collision? If you try to store an item into a particular location, collision occurs, then you have to resolve a collision, you have to find out a new address, you have to store the item. Suppose a item is stored to its place after the two collision. During retrieval also, it required the two number of collision is to be executed. Otherwise, it is difficult. You cannot retrieve it. That means the amount of effort you put to store the item into the table is directly proportional to the amount of effort required to retrieve. That's why the designer's choice is to develop a hash function so that you don't have to use any collision resolution technique. Once you use a collision resolution technique, it will be repeated for every retrieval from the hash table. So the example is the company has 100 employee. Employee number starts from 1001 to 1100. So hashing function subtracts 1000 from the key to determine the address. Okay, this is example how you determine the address just by simple subtraction. So that's why it's written direct method as the subtraction. Looking into the basic operations also you can design or you can thought of many uh, new hashing functions. So this is the most popular one. X mode 10 sometimes we use, but it is insisted that this X mode M and M should be prime number, and that is the process of designing a unique hash function. So this hashing method is the modulo division method. So it divides the key by the array size and use the remainder of the address. Okay, that means if my key is 7409, my table contains 10 locations, so I am using key modulo 10. Okay, whatever the value I will find, and that is the location where the information has to be stored. So algorithm works with any list size, but the list size is the prime number produces a few columns. So this is a observation, but this summarized, and most of the examples or whatever the problem we learn, we use this modulo function. And many people only knows that I can use a hash function key modulo 10. Again, it's an example. Okay. Again, it is an example. So the address space is computed. Key value is 7409 modulo 10. That is the number of buckets. That is the number of buckets. Okay. Next, the digit extraction. It is a some randomized method. If you look into this, a particular key value is given, and you try to pick up first, third, and fourth digit and store the record at that section. Got it? So if you look into the number 379452394, what I'll do, I'll just pick up first two position, second two position. I'll try to find it. So that is also one of the method, digit extraction. So here, whatever the digits you are extracting, you define the method. It has to be uniform for a whole set of key values. Okay, so here the example is the 6-digit employee number is available, out of which 3 digits is being accessed, others are not into put into. So what is the suggestion? Select first, third, fourth digit, use them as the address. This is one of the very simple mapping procedure, or you can say hashing method. Simply look into pick up some value, alter some value, fold some value. This type of activities are there. So this is the mid square. Mid square again is a number. You try to square it and pick up some bit from the beginning. Like this is 945. You square it to obtain 893400304, and then you are looking into address. Which one you will select. So how to implement it? That the first part you can do with the help of simple square. Then some author suggests, or somebody suggests, no, you pick up the last 3 digits. Somebody will say, no, you pick up the first 3 digits. So you have all the alternatives. You can decide, and you can have a hash function. But then the number of hash function you are defining has to be checked or analyzed, which gives the best performance. Okay, that we'll see how we'll compare the different hashing methods. So now look into that, selecting first 3 digits, that is 379. It got squared 1434, 641. So I am doing it for all the such 5 cases. Then we remove the other bits. Okay, so this is one of the method. In that way, if you look, you'll be finding, and maybe you will be curious, that it is something like I can write a randomized algorithm. I can produce different type of similar type of hash function. Answer is yes, you can do that. You can select a random type of, suppose here you are using one function to square the number. Then in another function you may be using only first 2 bits to square. Next you are using last 2 bits to square. So you can create different type of mapping function for the hash table. Look, so to design a hash table. So the hashing method is the folding. So folding method again is a mechanism. Either the number will be treated as a string, and you have to fold it. The number has to be assigned a value, and so that we can generate a new address. So here the folding method, or the type of folding method, gives you different type of hash function. Okay, so somebody said try to flap it from left side, somebody from the right side, somebody takes the two bits from the body and they add it up or cascade it up to call it as a new method, or the folding method of the hash function. So fold shift and the fold boundary. The fold shift key with value divided into the parts which size which matches of required address. So how the shift is to be carried out. The fold shift key value divided into 2 parts. Take a value 1, 2, 3, 4. You divide them into 2 parts, that is 1, 2, and 3, 4. Fold shift value divide the 2 parts. Size match, and size matches the size of the required address. Okay, my actual address is 2 bit, but my key space is large enough. That's why there I have taken 4 bits. So 4 bit has to be transferred to the 2 bit. Left and right parts are shifted. When you look into the number, we are shifting it by the next digit and added with the middle part. Okay. Once it added with the middle part, it gives a new key value where it will be stored. Okay. This is a Hash-fold example. This is a Hash-fold example. So the first one is the fold shift, second one is the fold boundary, and this is the number 1, 2, 3, 4, 5, 6, 7, 8, 9. So we change the position as if you look. 1, 2, 3 goes up, 4, 8, 9 come to the bottom. We have three numbers arranged one by one. Then we add them and we'll find that the particular transformation is called fold shift. Similarly, for fold boundary, we compute the address of the part of the key value, that is 123, 456 and 789. After that, we can sum up them to find out a new key value. It's not necessarily always sum up. You can use any other operation also. Some random, if you look into that, some randomization mechanism has to be there to manipulate a given key value. Assume that the key value is large enough. The key is more larger, the more experimental, the more hash table you can design. Okay. You can, if the key is small one and small in the length, so then it's not possible to design a unique hash function. The sixth method is the hashing function, that is called folding. So the folding example is like this. X is a number given a very large number. We partition the X into 1, 2, 3, 4, 5 parts. Okay. So then we simply add them. So somebody say, I will not add this last 20. You discard, got a address, that will do. Somebody say, no, I will not add the first 123. He also allowed, you will get a different value. So the mechanism is that we wanted different location for two different roll number, it should be unique. So to design that unique, this variable hash functions are discussed. But for your problem, which one is suitable, that you have to try out all this function, and that will be finding that my problem, if at all I am solving using hashing, this method is good or this method is fulfill my requirement, that need to be checked. Okay. So this is a Hash-fold example what we have discussed. Then this is the rotation. This is folding we have finished. So this is the rotation. Rotation is the cyclic clip type. If you look into the number 600101, so what happens? You shift the first position to the last position. Okay. The rotation is used in the combination of folding and the pseudo-random hashing property. Hashing keys are identical except the last character. The rotating last character of the front of the key that minimizes that effect. So that's why with that heuristic, what we try to do, the last number is written in the pink. That is that goes to the left hand side of the number. So these are the key before the rotation, and this is the key list before the and after the rotation. Okay. So rotation is one of the method. Then that is pseudo random number generator. Sometimes I just about to tell you that if a randomized algorithm you are thinking of, so that then many randomized algorithms are also possible, so that with help of them we can design a efficient hash function. Okay, so one is by developing an algorithm. So key is used to set the random number generator, and random number is scaled into the possible and address rate using the modulo division. Simply modulo division is to use. Most critical is that how to find out this number. Why it is called 307? Okay, why it is called 307? So there are some studies there how that number will be found. So your Sahni has Sahni discussed a particular theorem that it's recommended that this number should be a prime number. If this particular 307, that place is particularly a prime number, then we can have a very good hash function. Okay, so assume that this is a simple problem. You have a random number generator, that is y equal to x plus c. So y equal to x plus c, we put the problem. Then the prime number, which is 307, and this the most critical part, how to decide the prime number. A is 17, C is 7, X is 121, 267, but finding this, there is only one example available in the notes book, how to find it that. The problem, sometimes the question comes, you have given a table, you have given a hash function, and this part will be not given, and there is a performance index which is given to you. Okay, we'll come to that, how the performance index is calculated. Then you have to find out this prime number. Okay, so this is sometimes we will discuss that problem. This is one of the challenges, find out the suitable hash function, but a performance parameter will be given. I'll just come to the performance parameter, then we'll go back to the other slides. You see, just okay, I'll tell you. So sometimes when we look into the table, we calculate a factor that is called loading density. So when you look into a size of a table and the number of identifiers which are stored, that ratio is sometimes useful to decide that how you are, when you are designing a hash function, when you are designing a hash function, that sometimes taken as a performance parameter, or the average number of comparison required to retrieve the item. That means indirectly, if you have experienced a collision and you store it, the more that number of trial is required to retrieve. Okay, let us quickly come to the one example, then I'll tell you why it is difficult and how we compare. So here we have different collision resolution technique. Quickly, I have skipped few slides. We'll follow serially. There is a collision resolution techniques is called linear probing. So we have given a look into that. This is not a table. First you look, this is not a table. The table size is this first one. Okay, with address 0, 1, 2, 3, 4 up to 9. So these entries are the snapshot when the particular item tries to enter into the hash table. Okay, so we have only single slot per bucket. We have a single slot. So we are using a hash function. That is hash function is hash of x of y. Hello. So we start with 89. We start with 89. My hash function is x mod 10. My hash function is x mod 10. So x mod 10, 89, I'll generate a address. I'll generate a reminder, that is 9. Again I repeat, hash function is x mod 10. So it goes to this location, 9th location. Okay. Then the next number comes 18. 18 is also uniquely mapped to x mod 10. It goes to location number 8. Then I have the third key is 49, which also generates the unique address with x mod 10 is the 9. But the 9 place is occupied. Okay, the 9 place is occupied. 49 I try to store into a location which is occupied. So what is that condition? That is a collision. And as the number of slot is 1, we don't have any second slot where I can store the 49. So I have to, or this condition is called overflow. When the overflow condition occurs, then I have to store the item into a place by using this hash function. That is a linear probing. So linear probing, if you put this value, let us say 49, you got a reminder, you write here. A hash of x will be the value that is called 9 plus what is the fi? What is the fi? F of 0 equal to 0. Here, what will be the value of the fi? Can anybody say how I am storing into location number 0? I want to compute for the item HI. My hash X value for 49 returns me 9. So this value will be 9. What is f of I value? Yes. Can anyone respond? What is the f of I value?
Number of collisions.
No. Hash X. Listen. X is the key value. Okay. X is the key
F of
value.
I is I1.
I will be 1. Then this value is
Yes.
9. 9 plus 1 is 10. So you are applying the same mod function which h size as the 10. So it mapped to what is the h of ix. Got it? Hash of x is of 49 is 9 plus f of I is 1. 9 plus 1 10. Then this mod h size is 10. So 10 mod 10 is remainder is 0.
0.
0.
So that goes to the 49. Now let us come to the another item. So where I can store 99, let us say instead of this uh, 58, we got 99. What will happen? 99 first here we have a collision and overflow. Agreed? Already location is occupied, so it's a collision. And I mean, you get the same address, then you don't have any space, so it's an overflow. Now I tried 9 plus f of I is 1. Again, it will map to this location 0. And second attempt, so this is h, when that means when I'm going to resolve the collision, I start with first one. That is first attempt, second attempt, third attempt, fourth attempt. H of 1 of x. And now second time when I'll move for the h of 2 of x. Okay, that is hash x is 9. F of I will be 2. F of I will be 2. 9 plus 2 11. More 10. Remainder is 1. So it goes to this location if I store 99. But similarly, the same thing happens with 58. 58 I try to store, so there is a collision and overflow. I cannot store here. So what I will do here? 8 plus first one. I explained you something with 9. Now what will happens in 58? 58 first you could not able to store because there is a 8. This position is occupied by number 18. Now how you will apply this value? Sorry. How you apply this function? Hash of x will be 8 plus what is f of I? F of I is 1. Right. So it is a 9. 9 more 10 is 9. For the 9 again it is 89 is already there. So after that you try it the second time. So your h of hash of x will be 18. That is 8. 8 plus 2. 8 plus 2 is 10. That is also occupied because 10 more 10 occupied. Okay. Now you tried f of I equal to 3. So 8 for 3 is 11. So remainder is 1. So you leave the 58. So this effect you see, we able to store 58 after 2 collision. If we store the item like this, it will take more time to retrieve. It is more time to retrieve. That's why we have to minimize this effect. This is one of the agenda why we go for different type of hash table. Okay, and then comes your 69 as I have explained. 69 first overflow has to be occur here. Second, if you try to store, you will find 49 is there. Other than 58 is there. Okay, and after that 68 comes here. 69. So initial 69 will be mapped to this position. That is occupied. So first attempt, second attempt, third attempt. So fourth attempt, we able to insert 69. Similarly, for the retrieval, it will be goes by that same effort. That is the reason we try to design a hash function so that it will store without any collision, or even if it try to store, it will be minimum. That means averagely maybe one or less than that for a individual record. Few will be stored directly, only few will be stored requires one comparison. Okay. Well, do you have any class? Hello.
No, sir.
No, okay. Just I'll take two more slides. So theoretically, when you look into the performance of the hash table, so many experiments are conducted to simulate the find out by taking a set of key value and take a 3 or 4 hash function. You compare which hash function is good. Okay. So theoretically, the performance of the hash table depends on a method used to handle the overflow technique. We jump to discuss that one, that linear probing, and the independent of the hash function as long as the uniform hash function is used. So these two key terms to be remembered. You must remember the definition of a uniform hash function. Again, I repeat that probability that the location, that probability that if you have n number of key value, then I have a probability that my n number key value, n different key value will be mapped to the location, any location in the hash table. That average is 1 by n. Just like you have n number of elements, you try to select a element. So that probability is 1 by n. Suppose you have a n number of locations, or you can say it n number of bucket. Then whenever you select an item, it has a probability that it will enter into that bucket with a probability 1 by n. Okay, probability 1 by n. So overflow handling technique and uniform hash function. So in reality, there is a tendency to make a biased use of identifier so that we can design such function. Many identifier in use have a common suffix and prefix. You see, this is one of the observation, the identifier which you are using as a common suffix and prefix. That means you are using 2211, 2213, 2214 like this. So key values as the common suffix and the prefix or simply the permutation of their identifiers. So therefore, the different hash function would give the different performance. Are you getting me? Suppose you try to design 20 random numbers out of a 24-digit random number. You have written a random generate routine. Randomly generate 20 number and try to store them into a hash table. Again, you generate another 20 number, you will try to store them into the hash table. You will be finding the different formulas. This is a finding. This is a finding that the identifier is in use have a common suffix. Naturally, then just like we simulate some pre-sorted, semi-sorted like that. So somebody may ask to simulate the algorithms with the key value where suffix are identical, where suffix are different, where suffix 50% suffix are identical and 50% suffix are different. Okay. So this is the last slide. This is the observation. It's creating problem. This particular term, okay, let me remove this one. You see, look into this particular term, that is alpha equal to n by b. This I told something in a question, it will be given. This value is given, and you are asked to select a hash function, and you have selected a hash function. Let us say x mod 10. Then you have different varieties as possible. One is the chain one, and another is the open one. Okay, so and then you have got different type of hash function, and you have a modulo one. You can take one. You can go for mid square, only square, and you can go for division. You can go for shift, holding different type of hash function, or you take a X mod 10. Only vary these things in the, that is n by b, you will vary, and conduct the experiment for the hash function with open hash table and a chained hash table or a closed hash table. So you have a very good performance in the uh, tabulated, subjected to how you generates a set of key value. If you randomly generates, you have some performance. So one can do a very small exercise. Let us take a fixed size of hash table. Let us take a set of random key value. Again, we'll fix maybe out of available hash functions. You compare 3 to hash function of your own. That is, what is the average number of collisions required to store an element or to retrieve an element. One parameter. Average number of collisions required to store an element to retrieve an element. Okay. So you'll be finding when you run the algorithm time to time, it will vary, because this justifies that, therefore the different hash function will give a different performance. I am generating, which is nothing but the permutation of the digit to decide a key value. So generate the key value randomly, and or with a different distribution, or simply you can generate with any random generator and use different hash function. Generate one once, let us say 100 numbers, use compare 4 different hash function. Again generate again and use different hash function. So for those things you can say random cases, and then you can go for the common suffix. Generate again 50 numbers with common suffix, then again generate 50 numbers with common prefix, and first one I told about randoms. So you can compare any of these techniques, or select at least 2 techniques. Let us select mid square and the digit extraction, and compare, simple compare, how many collision occurs. How many collision occurs? Then you can plot the bar graphs for that. How many collision occurs? Maybe after comparing one or two, you can consider all these hashing hash function and have a conclusion. Then you are finding none of the, the average number of collisions are 10 or something like this. Then something new comes to your mind. You simulate that one and claim that I developed a hash function where number of collision is less than the conventional hash functions. Okay. Let me quickly look into the what type of exercise we try to do like this. So this chapter mostly we ask for the problem. You see, draw a 11 entry hash table for a hashing function. So is it easy? It's very easy. You have the key values. 11 entry hash table is there. How many slots are there? How many buckets are there? Bucket number from 0 to 10. So because there are 11 entry hash table and with a single slot. Then you have the key values 12, 44, 13, 8, 88, 23, 94. So you try to store them using a hash function 2i plus 5, 2i plus 5 mod 11. So there is two suggestions. Either you have to use the collision resolution techniques, that is closed hashing or linear probing. Okay, use the closed hashing. Closed hashing is the hash table. Linear probing is the collision resolution technique. Then you come to the question number 3. Draw a hash table with open addressing. The size is of 9. Use the hash function, that is x mod 10 or k percentage k mod 9. It is x mod 9. Then you have to insert these keys, and the address of the table you can start from 0 to, the size is 9. So 0 to 8. 0 to 8. And then you have other questions such maybe it's a very long list of questions not included in this particular PPT. So draw a hash table with the open addressing of size 9. Use the hash function. This, suppose an open hash table has a capacity 811. Now you look into this question. We just have entered again. And here in the question it is written approximation is fine. I told you that this hash function x mod 10, actually this 10 we called it x mod m, and we tried to find out that m to be a prime number. So you see, open address hash table is given which has a capacity of 811. 811 capacity means we have number of rows and number of columns. So if I'll go for B number of buckets and S number of slots, B and S will multiply to give you 811. Okay, and it contains 81 element. So that is n value is 81. So what is a loading density? Please note it. What is a loading density? That is 81 divided by 811. N divided by SB. Okay, again repeat again. N is the number of element, S is the number of slots, B is the number of buckets. So this particular value, suppose I have got B number of buckets and each slot is capable of taking 2 elements, so it will be 2B. So the loading density here we calculate N. N is the number of key value to be stored to the hash table, that is 81, and S, this is the multiplication, slots multiplied with the bucket. So then it asks you to select a suitable hash function so that they call it a particular clustering effect, I'll explain you, or a number of collision will be minimal. So there are some tricky questions. And one of the proof it actually refers to the Nuth. I'll let you know that actually no proof is there. Sahani book only maps to the Nuth to for that particular proof, and we'll be using that one. So I'll be posting these things. I have not posted. I'll be posting many articles related to the hash table. And there are 2 articles which is quite popular. I mean, and at the end of this presentation, we have the Kuko hashing, just an introduction for your reference, not part of your course. I'll upload the things just now. Okay. So any question from anyone? Sorry that little bit of disturbance because of the non-availability of the power in my residence. I have to come to the institute to take the class. Okay. So hashing, any of you have completed it during undergraduate course? All the problem solving in particular. We have the dynamic hashing also.
Just the implementation.
Implemented means?
Just created a, I mean, user-defined hash table using rehash load fact.
Okay.
Those things.
No, I told you last class to look into the scope that at least you know that what are the default hash table available in Java. Is there any default hash table available in C++?
Yes, sir. Unordered map and ordered map.
Yes, I think it, I mean, those people have no information. Please listen to and share this information with your friend because this is very much important. Nowadays, these languages like Python and others, why they popular? The first reason is that all the data structures are inbuilt. I mean, whatever we new data structure we define, people made it available through a class file or as a library function, and you have to only to use those things for the application. So this is a twofold actually. Either you use it and or you study and you come across a problem, you have a limitation, you try to enhance that data structure. Okay, we have programming assignment also in the related to the hash table. I mean, those who are in the lab actually they are taking advantage of that. Otherwise, if all people are interested, I can share them the assignments. But it's a good thing to, that at least you know. That's why I have told the two books, the Adam Drozdiak. At least you have the information that how to Even if you have not written a program, you have an immediate answer that if you want to create hash table, why you are trying to write your code, go to your either go to for the Java or you go for the any other in C++ or then we. Is there anything in Python? What is the facility available in Python? Anybody knows for hash table? No idea. If you look into the good books, good book on Python, data structure and algorithm, because I think I told you a blue color book I have shown you from the beginning, that is Goodrich and Tamassia. Goodrich and Tamassia is from John Wiley. They have the book, they had the book on C++, then they had the book on Java, and they had the book on, now the book is on the Python. Okay. So these books are like this. You will never find a complete program, but you'll be finding only class file or hints how to use it. Okay. If you'd like, I'll share the details. Yes, please.
Sir, generally, sir,
said Goodwill, I guess.
Goodrich and Tamassia. I'll share the details. Goodrich and Tamassia.
Sir, for Python also. For Python also, there is a book on this by this publisher also.
Yes, data structure in Python is by Goodrich and Tamassia. But you won't find the codes completely. Okay. I don't suggest to buy that one because I used to teach one person called internet algorithm from that book. Internet algorithms are nothing but the string matching algorithms. But you should explore the facility for the GitHub. Any of you have created GitHub profile? Any of you have created GitHub profile? You see, nowadays it's must, I think once I told, but you have to be active on that front because the placement and other offers are coming from that, and sometimes some good intensives are coming. And if you are enhancing a data structure like this, let us say, look into a very simple hash table. If you start creating a hash table, then you are adding 3 or 4 functions, and you say, I have designed a better lookup for a particular application. Okay, there is some real world application is there. You are finding the hash table will be, the hash table you propose will be good. So these small things are, I told from the beginning, the start of the hashing, one of our ex-PhD student, her work was on biometric, but she wrote 2 chapters of her PhD thesis because I think she has not studied extensively the hashing. When she found that, she said, okay, very simple idea. Let me use this hash function to search a biometric database, and that becomes a novelty. So this type of mindset you should develop. Problem is old, technique is old, and you become the first person who maps the technique to the problem. Then you becomes becomes a new finding. Okay. So similarly, some database, I just say, let us come to the DNS. Can I design a DNS using a hashing technique so that we can search very fast? We know search on binary search tree. We know the search on the linear array. We know the search how to carry it out when I am using a data structure, like tree-like structure. Then comes the hashing. Hashing is the first searching techniques. So let us look into an application. And that application made you popular. That means if you want to write a very small project, let us say, this thing I'm repeatedly telling you, you write something. Suppose you did some project related to the hash table. When you tell the interviewer, he may not appreciate the hash table. You have to change your problem statement that I have developed a faster DNS lookup. Then question will come, what is that faster DNS lookup? What is a DNS? What is a DNS lookup? What is a typically disadvantage with a DNS if it is maintained in a linear array or circular register like this? And then you can say, no, sir, I have compared 3 or 4 DNS lookup techniques, and my proposed hash function gives me the best lookup. Okay. So something has to be there, and maybe if you are writing the code and you made it available to the public, you can publish in the GitHub. One of our students, he developed certain wireless network simulation, some modules. At that time, the MATLAB, in fact, was doing the same thing, and he developed those toolbox in the MATLAB and released it for the public use. At that time, GitHub was not there. GitHub was not there, but equal opportunity is there. If you try to develop with the MATLAB, you can do that. Okay. So we'll conclude with this. Okay, about the extra classes, what are the time in second half you are free?